everyone. Welcome to our PBICT STEAMY Robotics class, and this is lesson number 2. So I just want to introduce my class to you. I have a total of students, and best believe we are socially keeping it in distance. We also have some sanitizers so that we adhere to the social distancing rules for this lockdown. COVID-19 that we have. Okay, so I just want us to first recap on our first session, which involved the introduction to robotics. Last week, we discovered that robotics are actually, or robots are actually all around. Made examples of our everyday robots that we see. Does anyone remember what? Yes, Louis? Okay. Can you speak a bit louder? Can you shout? Because
robots are programmed to do certain things that you want them to do. You can make them work, or some of them they also computers laptops or any phone. So they program to do those certain things.
Okay, so Louis, let's not forget that when we talk, we need to put our mask on. Yes. So yes, good, Louis. That's actually a great answer. So robots are programmed to do and perform certain tasks. Mainly, some of them are tasks that humans cannot do, or that actually make processes more efficient and easier, like a car, for example. A car is a robot. Today we take a car so that we can get where we want to get quicker. Okay, so another question that I want to ask you guys, do you remember what human traits make a robot? What human-like traits? Remember touching, feeling, what is it called? Yes. Okay. Let's have one answer. One answer. Yes. It's senses. And what do senses do? Yes, Louis? Okay. So they sense if something's approaching. So what sensor would that be? Yes? Okay, close enough. Yes, Suntolile? An ultrasonic sensor. Okay, so an ultrasonic sensor is able to measure a distance between you and the object, or between the object and another object. For example, what we have in our gates, right? Every time we touch our gates, it moves back. That's how an ultrasonic sensor works, because it has calculated this distance between you and the gates, and then it will stop once it senses. The rule of thumb for some gates is actually 5 centimeters. So once it senses you at 5 centimeters or even more, it can actually stop. Okay. Yes, Ente? The ground. Okay, so Ente is saying, yeah. So Ente is saying, when you go looking for treasure, just like you do in the cartoons or in TV, they use this big thing that goes around in the sand that looks for gold. And Ente says an electronic sensor exists in that machine. Is that true? Okay. Why would that be true? Yes. Okay, so there's a mixture of sensors in that. Actually, it could be a magnetic sensor because it needs to sense metal, so a metal sensor. But we'll go deep into those things a bit later. Okay, so today we are now actually going to be building a robot, and once we build the robot, we are actually going to test it, right? So I'm going to go a bit deep today, but not that much. Okay, so we have one important lesson or one important principle that we have when building robots. Does anyone know what that principle is? Yes? Yes. The most important thing to do when you want to build your robot is to always follow your instructions. Why? Yes, Enhle? Yes, the instructions tell us what to do to make the robot. What if we don't follow instructions? What happens, Louis? Okay. Okay. So Louis says you'll end up getting confused and you end up not knowing what to do with the robot. But can you imagine if someone, an engineer, robotics engineer, built it, made a mistake? What would happen? Right? Yes? Yes. It will probably crash and malfunction. So the most important thing to ever do when you build a robot, listen and follow instructions. Then you will be a great engineer, okay, or a great robotic engineer. Yes, Ente? Yes, and also focus. Okay, so that's good. All right, guys. So let's start. Okay. I need us to all take our heads, our robotic heads. Let's hold them. Our brains. Okay. Okay. Right. Okay. So who took the one that was supposed to be here? Does anyone remember? You did. It's fine. Just remember. Okay. So they are currently holding the head. So I'm just going to show you. Can you please borrow me? So I'm just first going to sanitize first before I take components, because that's what we're supposed to do. All right. So this is called the mind of the computer, of the robot. Okay. So it's actually also the computer. This is where all the instructions are stored. This is where all the instructions are sent out to our outputs, right? Okay. So in this, we have output ports and we have input ports. Okay. So our output ports are the ones that will be connected to our what? Does anyone remember outputs? Outputs is B and C. Yes. So our output ports are connected to motors, right? So what happens is the computer sends an instruction to the motor for it to rotate. Once it rotates, there's an output movement, which is actually the moving of the wheel, right? We then have input ports. Does anyone remember what goes into input ports? Our, yes, yes, great, right? So do we all remember how sensors work? So our sensors gather information around our environment. For example, if you have a temperature sensor, it gathers the temperature and then it sends the temperature to the brain of the computer or the robot. And then the robot is able to process that information and decides what actions to take from that point on. Yes, right? So all our inputs go into these cables, right? So I'm going to give you one exercise to do, right? I need you guys to please connect all, I need you to please touch sensor. I need you to please connect your voice or sound sensor to your heads. Okay, I also need you guys to please connect your motors, but don't touch this. Yes, Louis. You don't have a touch sensor. Okay, cool. Please look, sanitize first. Yes, sanitize first. Right, let's sanitize first. We sanitize before. Yes, great. Okay. Okay. Can you borrow this? Okay, you don't have to. Okay, there you go. Okay, so we're gonna look for them. Okay, it's fine. You can put any sensor that you can see. Your ultrasonic sensor, because we're gonna use the other parts. Yes. Okay. All right. So I'm just going to show you what the sensors look like. Okay. I'm going to show you on this screen that's over here. Can you guys see it? Okay. So this would be what you call a light sensor. Okay. That you would put on your robot as the input. Okay. So it would gather the light intensity surrounding on the surroundings, also the color, the type of lighting, and once it gathers that information, it is then able to process it on the brain and decide the action. Okay. Okay, so this is called a light sensor. Okay, thank you. There we go. Does anyone know where we can use light sensors? Yeah? Yes. Mm-hmm. Okay, all right. Okay, so the most common application of a light sensor, right? Some homes actually have these self lighting lights, so they just light. Or even around our streets, you know, at 6 o'clock, you know that the lights are on. Okay, some of those lights, how they work is they sense. Okay, just like in your cars as well, the automatic cars, they can sense the light intensity. So when it's dark, you'll see that the car will start actually having its lights on, and even in our homes, when it starts becoming dark, you'll have our lights on. All right. Okay, cool. Okay, so everybody has done that. Okay, so we have a touch sensor there, port number 1, right? Okay, okay. Can we also put in our motors? Okay, just one motor is fine. Okay, it's fine. Okay, we'll just use one person to show us if the motor works. Okay, right. So what we are now doing with the class is that we are actually testing whether our sensors work. Okay, so what should happen is that if we touch the robot, our motors should make a noise. That means our motors are working. So we have an input, which is the touch sensor, communicating to the output, which is the motor. So let's check. Okay, so yes. Whoa. Okay. So I'm just going to show you, Luigi, you want to show them what you did? You want to show them what you did? Okay. Okay. All right. Okay. So you will operate on a touch sensor. Okay. So I'm going to show you the program that Louis did. So unfortunately, it's not as clear, but hopefully it is. So Louis actually programmed, right, a function that tells the robot to run the motors when being touched. Okay, so let's test it. I'm just going to run it. Okay, right. I'm gonna run it again. Okay, it's still running. Okay, so let's just do that again. I'm gonna touch. You see? Okay. Thank you Okay. Thank you, Louis. Well done. Okay. Well done. Okay. All right. So another sensor that we have is called an ultrasonic sensor. Here it is. It's got these eyes, and its basic function is actually to measure the distance between two objects. Okay, so you have this right in your gates, this in the cars. Okay, so how does it operate? Okay, this actually measures the distance, let's say for an example, between you and the gates. And then once it does that, it sends an instruction to the computer and to then the motors for the motors to stop working. And that's how the gate stops from hitting the gate would hit you. An ultrasonic sensor also exists in cars, right? There's an ultrasonic sensor attached at the back and sometimes at the front of the car. It measures the distance between the car and the object. And that's why you hear a car going doo, 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 all the time, so that it warns you that you are then too close to the distance. This is what it looks like. Okay. Yes. Okay. Let's go to the next component. I'm looking for a touch. I'm looking for a sound sensor. Yes. Okay. So this is what a sound sensor looks like, right? This is what a sound sensor looks like. It senses obviously sound. It actually also is able to do some voice recognition just a bit. It's able to make out as well what word you're saying. So for example, if you say okay to it, it's able to take that signal, put it into a computer, translate it. So the next time that you say okay to a robot, it performs the certain output that you want to do it. Okay, so we'll test this as well. All right. And we have our touch sensor that we've been testing. And you see it. Touch sensor just says, if you touch me, I will output a certain function. Okay, right. Okay, so this is the light sensor that I showed everyone in the beginning. Okay, and then this is the motor. Okay, so this is what the motor looks like, and this rests on our outputs. Okay, right. So now that we're ready to go, now that we know we're all familiar with our components. Oh, before I forget, there's actually also some other very components that I need you guys to be very acquainted with. Okay, so when building a robot, besides the mother or the computer, or besides the sensors, what else would you need? I know, we haven't discussed this, but I need you to think. What else would you need? Okay, it depends what robot. Let's say you want to build a robot that is like a what? A dog. Okay. Okay, let's try a dog. What would you need? You need a okay. Besides the sensors. Okay. Legs. What are legs? What is it gonna move with? Yes. Uh-huh. Food for robots, nice. It must also have eyes and a nose. Yes. Okay. So what else? Okay. So basically, other than the sensors that we've already talked about, you also need what they call links. Okay. These are your mechanical links. Okay. These are your building structures. Okay. These are the things that help you create what you create. So, for example, this could be a claw. Let me show you. Let me show you something up close. Okay, this could be a claw, right? This could be a link. And then most importantly, to move around, we need tires, right? Because we need to move around with the robots. And the toys usually always, not not usually, they always have what's it called, or an axle, okay, right? Because the axle is what communicates to the motor. Yes, well done, right? So the motor actually communicates to the axle, and then the axle communicates to the wheels for rotation. Rotation is called circular, it's what you call circular movement. Okay, so now that we have an idea of all the parts that are actually across this whole table, we can then start to build our robot. Who remembers the name of our robot? Yes? Yes, it's 5 minute bot. So it should take our team 5 minutes to build the bots. Okay, does anyone have a timer at home? I hope you guys are testing. Let's see if they're going to be quick enough. Okay, so they have a set of instructions in their tables right here, and they need to build this robot together in 5 minutes. Okay, so don't forget to sanitize when you pass the. Remember, everything is here. Okay, yeah. Don't forget to sanitize. Okay, right. So the queen over here is starting. Okay, 5 minutes. Okay, right. So when they're done building the robots mechanically, right? Because they're first creating the structure, we're then going to move on how to program it to do whatever we want it to do. Okay, so there's two ways to program a robotic kit or an NXT robotic kit. Okay, by the way, these are NXTs by Lego. They currently are, in my opinion, the best. They look like toys. Everyone says it's toys, but these robots are so powerful. You can build any sort of robot using Lego. If you have time, I challenge you to Google Lego Mindstorms and see what projects have been created using Mindstorms across the globe. Then you'll see how powerful these robotic kits are. Okay, they're not toys. They're not toys. They're actually quite magnificent machines. Okay, their capabilities are quite tremendous. You can build conveyor belts. You can build autonomous vehicles. You can build so much with this. Okay, so as I was saying, there's two ways that you can program your robot to follow certain instructions. Okay, the first way, right? The easiest way, the way that we're going to do it today so that we get a hang of our equipment, we are actually going to program it inside the computer itself. So when I say inside the computer, my apologies, I mean the brain of the the brain of the actual robot, okay? So you can actually program your robot to follow certain instructions here. You can also program your robot via your laptop, okay? So we will then begin that journey next week where we go into depth of the real programming on a PC, on a program software, where we will be exploring functions such as loops. Um, we will be doing a lot of programming as of next week. But today we're simply going to do the simple one that focuses on the computer. Okay. So I'm just going to switch this on. I hope you can all see it. It's called Mindstorms. Okay. So what I'm going to do is I'm going to choose a, okay, let me just, I think it's this one. No, take this one. Okay. Sorry about that. Can you give me one? Thank you. Okay, so let's view again. Let's come close again. Let me just take you through. Thank you. Okay, just go back. Okay, so the first thing we do is that we turn on our computer. Okay, and we have many tabs here. As you can see, we've got my files. Okay, we've got NXT program, which is exactly what we want to do because we want to write our own program using this PC or using this robot. Okay, so this is what we select. And right, we are then able to see here, I know it's not clear, but it actually tells you where each input and output goes. So your inputs are all in your 1, 2, 3, 4, right? So this would be your input here. So it tells us that our first input is actually the touch sensor, which goes to number 1. Our second one is the sound sensor, which goes to number 2. Our 3 is the light sensor, which goes to number 3. Number 4 is the ultrasonic sensor, right? So that's in our inputs. In our outputs, we have B and C for our left and right motors. Okay. So before you start programming your robot, you need to obviously attach all your sensors and your outputs, which are the motors. Okay. So I'm just going to do that quickly for you right here. I simply take this banana cable, right? I link it to my sound sensor, right? And yeah, that's it. I'm connected, right? I can also take my touch sensor, which is the easiest one to do a demonstration. And I can put it on number 1 because that's what they said, right? And then I can put my motor. It's fine. I'll put an output. I just simply connect that. It's already connected. I put it on port B or C. I put mine on port B, right? Okay. How's it going there, 5-minute people? Are we really finishing this robot in 5 minutes? Oh, come on. Who's getting us? It's a 6-minute what now? Okay, all right. Sorry, let's focus again here while we wait for the other people. Okay, all right. Okay, so once we've connected our sensors and our motor, we can then run a simple program that speaks to the computer and then speaks to our inputs and outputs, okay, or vice versa, okay? So I'm just going to select a yes over here. So as you can hopefully see, okay, right? You can see, I hope you can see, guys, I'm sorry. We have five blocks, okay? So does anyone remember what I said, what a computer works on? That one word, yes. Yes, but there's a way that we communicate to it. Yes, good. It's programming. Okay, so this is a form of programming. And a robot or a computer understands logic, right? It understands things that are step by step. It doesn't understand just organized, and you need to give it steps. You need to give it instructions step by step. Okay. So next week we will go into more detail on the programming. Okay, but for now we'll program it on this robot. Okay. So over here you have a set of instructions that you can give to the robot. You can make it go forward. As you can see, it's written forward, and then you have 5 for 5 seconds. You can make it go forward make it go backward for 5 seconds, right? You can make it go forward forever, right? You can make it turn right for 2 seconds, turn right forever. You can make it go turn back right. You can make it sing. You can make it sing a bit longer. You can basically make it do anything. So what should I put on my first step? Okay. So on my first step, okay, I'm going to tell you what I've chosen and we'll see if it works. Okay. On my first step, I want my robot to sing, right? Okay. So it must sing. On my second step, I want two inputs attached because when I want to touch it, I want it to move forward. So my second step will be putting a touch, right? Just going to put a touch here, right? My third step is I want it to go forward for 5 seconds. But as you can see, I haven't attached any wheels, so it won't go forward. But how will I know that it will go forward? Yes, so I would know that it will go forward if I hold it and I hear the sound of my motor moving. Why? Is my motor connected to my wheels? Well, not yet, but yes.
It's because
Yes. Yes. So Ente says the motor is responsible for making the wheels turn. But if the wheels are not there, the motor will turn by itself. Right. Okay, so let's select. Okay, so I've selected that. And then I'm just going to make it I'm just going to make it stop at that point. Okay, so I've used only 4 blocks. Okay, so I'm also going to attach my sound sensor because remember I said it must also have a tune. Okay, so I need my sound sensor. Yes, it's on here. Okay, so at the very end of your simple set of instructions that you've given to your robot, it gives you an option to stop or it gives you an instruction to loop. Okay, meaning that it will continue for infinity until the battery dies. Okay, so a loop means infinity. So it means it will carry on around until the battery dies. Okay, but we wanted to stop, meaning we wanted to execute these 4 steps, and after these 4 steps are done, it will just stop. Okay, so let's go. So I'm just going to say stop, and then I'm going to run. Right?
No, Jabulo, could you please just repeat that? We just lost you guys for a second. So I think you will last just 2 seconds.
All right. Okay, so we're just going to run this again to test if it works. Okay. Okay. Okay, we're just going to do the sound one for now, not the motor, with this one. Okay, so okay, right. Okay, so we're running it and we're testing the sound sensor. Okay, so let's do it. Okay, right? So we know that our sound sensor is working based on this algorithm. but we have a problem with our motor, so we're going to fix our motor shortly to also test our motor. Okay. Okay. All right. Thank you. Okay, so I can't touch you guys. What's going on? Are we finishing? Okay. Are you winning? Okay. Calm down. It's okay. Just follow the instructions. Okay, follow the instructions. Remember, you're almost there. Okay, so whilst we wait for our people to finish our now 15 minutes robots, I'm going to be answering some questions. Okay. Okay, so the first one is, how can your child be a part of this training? So please email robotics@pbict.org.za. Right, so it's robotics@pbict.org.za. ROBOTICS@pbict.org.za. Okay. Okay, so okay, everyone can hear me. So I'm just going to give some of our viewers the ways in which you can ask questions. I'm not too sure if everyone has the details, but if you have a question, just please go on to www.menti. So it's M for mother, E for elephant, N for naughty, T for Tom, I for intelligent, .com, right? So www.meti.com, and you can use the code 9225. Okay, you can ask questions, make comments so that we can receive them. Okay, so another question is that we'll be learning to make a remote control robotics. Okay. So sanitize, don't forget to sanitize, guys. Sanitize. Yes, let's all sanitize before we bring the robot. Okay. So the question is, we will be learning to make a remote control robotics. So somebody wants to know if whatever we're building or we will build in the future, we will be able to use a remote control. That's what I'm getting from this question. I hope it's answering correctly. Okay, I'm getting it correctly. Yes, definitely. Actually, we will be able to make robots that we can control using an app. Okay, right? That's where we will get to. Okay, so that's one of the nice things that we'll be able to do. And after we're done with these robotics, we can then be able to use any other platform to build any other robot. So it doesn't have to be Mindstorm. We can use a lot of other kits to actually build our robots. Okay. Other question is, can you order the kits for your kids so that they can also do practicals? Yes, you can. Can you please send that query to pbict@robotics.org.za? Okay, so all questions pertaining wanting to buy kits and wanting to become part of these lessons, please forward it to, oh, my bad, it's robotics@pbict.org.za. Okay, getting a bit confused. So it's ROBOTICS@pbict.org.za. Okay. Somebody says that they know the boy that is wearing a black mask. They go to the same school. Okay. Okay. Louis is a celeb now, so you can say hi to your fans, Louis. But let's say it hi in a robotic way, like, you know, yeah. Okay. So thank you so much. Somebody's saying that they're enjoying the class. They're very impressed. The kids are informed. Well done, guys. Well done, PBICT. Yeah, so basically that's a compliment. Thank you so much, guys. Yeah, everybody's impressed with you guys. So well done. Keep going. We're almost done with the 15 minutes. Yeah, so we can test it. I don't know. Okay. Okay. What about these two? Okay. Remember, guys, instructions. I know it feels like you can do this on your own without looking at the piece of paper, but you'll find that if you don't follow the instructions, you'll need to start again because you've made a mistake. Okay. So that's the most important thing. Follow instructions. Okay. Okay. Mm? Okay, so I think this is what you're looking for. Remember, it's in this box. Okay. Yeah. Yes. Okay. So Louis is asking. We put everything in this box. All right. Okay. Let's look here. Okay. All right. So Louis is asking if we'll be programming the bot. Yes. Okay. So after we've built our mechanical structures using the links and we've put the wheels on our robot, we then have to program it for it to perform certain functions. Okay. Yeah. Thank you. Okay, so I'm trying to keep it social distance and helping my team here. Robots. Okay, we're almost there. Okay, so while Enter is building our robots, can we please put aside our box of components so that we can test it properly on the table? So we'll just put it underneath the table, okay? Right? Yes, okay, you can leave aside your sensors, just all the sensors and the cables, okay? So one of each sensor. You can just put it underneath your table wherever you are because we'll still need it. Okay. Okay, so are we done? Yay! Can we give them a round of applause? They finished the robot in 15 minutes, the 5-minute bot. So I think we should change the name of the robot. Okay. All right, so now we're gonna do some nice programming and we're gonna test the robot. Okay. You want to? Please louder, Louis. We can't. Oh, okay. So Louis says he wants to program it. Okay, so we will all get a chance to program it. Okay, and we will all get a score, and we'll see who wins. Whoever wins gets the most pizza. I don't know if there is pizza, but okay. So we'll run a little competition. Okay. So your challenge is to make the robot go 5 seconds, and when you touch it, it must go forward another 5 seconds. Okay. You have to program the robots, remember? Yes. Okay, so I'll help you. Okay, do you have all the sensors? So Ente's gonna connect the sensors. Okay, so we need 2 banana cables to connect the motor. Are the motors connected? The motors? Yes. Motors connect to B and C. Yes. So let's test our robots. Okay. Oops, I should have moved this. Okay, we can just put this underneath here. Another important thing is that these pieces are so small. And the reason why it's important to work with these small components, remember, even cars have little small things they call seals. Sorry about that. Okay, let me just see. Okay. So remember, even cars, they have little seals. Cars have little bearings, ball bearings, all sort of components that are small. And if you miss one component in a car, it's over. So that's why it's so important to make sure that all your components are neatly stacked after every lesson and that you keep them in order. Okay, so we're ready. Okay, so Anchor has programmed something for us. We're going to see if this robot. So what do you want your robot to do, Enche? What will it do? Oh, so you want it to run. Okay, let's see if it runs. Okay, so it sort of runs, but we have a problem. Okay, the wires. Oh, I'm not supposed to touch you guys. Sorry, let me just put some sanitizer. Yay! Okay, so Enche, it ran. Can we give her a round of applause? Okay. Right. So we can see that even our touch sensor is active here, but we don't know what it's doing yet. Enche knows. Okay. So the next person to program the robot is wants to be the next. Okay. Let's start with Louis. So Louis, you may not need all these sensors that you have. Okay. You may not need them all. So do you mind telling us what your robot will do? Okay. Louis says it's going to go forward, it's going to touch, it's going to stop, turn. Okay. All in 5 steps. Remember, we only have 4 or 5 steps that you have available. Will it be able to do that all at once? Okay, let's try. Let's try. That's the way that we learn. So it's gone forward, but it keeps getting stuck because of the wires. Okay, so let me just help you guys with the wiring a bit. We may have chosen long wires. Okay, are you sure you're going to use all those sensors? Because you can take one of them out that you don't need. the lights and the ultrasonic sensor, not yet. Ultrasonic sensor, we program it properly using a laptop. Okay. Okay, so did you count? It was 5 seconds. Well done. Okay. And I think you meant to touch it. Did you want to touch it so then you have to stop? Oh, okay. So you're programming the game. Okay. So who's next? Okay. Ladies first, I'm sorry. Oh, sanitize. Sanitize, sanitize. Okay. Good. Right. So you go, girl. And then you tell us what your robot will do. And then I'll show you what my robot will do. Okay. Okay. Nice. Okay. Okay, so do you want to explain to us first what you expect your robot to do, and if to see if that goes hand in hand with what you program your robot to do? It's gonna go forward 5 seconds, everyone. Hope you're counting. And backwards 5 seconds. Whoa. Okay. All right. Let's you hoping. Okay. All right. Let's see. Let's see. I want to make sure. Okay, but what do? Do you need to touch it first? Is it? Okay. All right. Let's see. I want to see. Okay, so you can run it. 1, 2, 3, 4, 5. Oh, wow. Look at that. Look at that. Okay, so it went forward 5 seconds, backward 5 seconds. Okay, so next person. Okay, so before you run it, I want you to tell us what it's going to do so that we see if you've programmed it correctly. Seconds, forward for 5 seconds, everyone, yes? Okay, for how long? Forever. 5 seconds, okay. Oh, okay, when you touch it, it's going to do a loop. Okay. Okay. Yes. Yeah. Okay. All right. Okay. So it pushes it around. You set an arrow that shows the right. Okay.
Hi all. I think they're having connectivity issues again. Please be patient. We should be back soon. I'm just double checking to see if all is well. Okay, cool. We seem to be back. Okay. All right, Nonjabulo, I'm giving you the floor. I'm just speaking to the audience as they were watching, as everything froze for a second. Just give me a second. Let me get you back online. There's your class. Thanks, everyone. Nonjabulo, you back on your class?
Okay. Do you remember where okay, I'm not too sure where exactly we ended off, but I'm just going to explain. Yeah, but I don't think they heard that. Okay. So I'm just going to go through a principle that was a mistake that Simtonile made. Simtonile, can you explain what you wanted your robot to do? Okay. So Simtonile wanted to go forward for 5 seconds, backward for 5 seconds, and he wanted it to make a loop. But it didn't do that. It went forward for 5 seconds, backward for 5 seconds, and then it stopped. Right? But then when he pressed again, it started all over again. So there's a misunderstanding between that loop and the loop that he wanted. Okay? So he pressed the wrong instruction of where it's after you actually program your robot and you want to tell it whether to stop once it has performed its sequence, or you want it to infinitively repeat the process until the battery dies. So that's what Simtonile did. If Simtonile wanted his robot to go round and round and round, he would have went to his motherboard and he would have selected the action that says turn left or turn right, but for how long? Okay, so if it turns right or left for 5 seconds, remember it will stop. But you said you wanted it to loop. So you must make it turn left or right forever. Right? So that it will go like this forever. Okay, so let's go. Let me show you what you wanted to do. Okay, just going to write a simple program. Okay, so I'm going to make this robot just turn right until I touch it. And then after I touch it, I just want it to go forward. Okay, fine. They want me to make the robot sing. So after I touch it, the robot will sing. It's gonna make a sound. It won't really sing. Okay? Right? Sorry about that. Let me just show you. Okay? So this is my 5-step program. I want to make it go round and round and round forever, like what Simtonile wants it to do. But after I touch it, I want it to sing. Right? You guys paying attention? You want it to sing, right? And then after that, I just wanted to wait 2 seconds. So what Simtonile did after he programmed his robot, he came here. I'm not so sure if you can see. So after he's done doing the program or writing the set of instructions, he then says loop. And he thought that by saying loop, the robot will move around and around and around and around. But that wasn't the case. It simply means that the set of instructions given to the robot would run infinitively until the robot dies out of a battery. Okay, but I'm just going to say I want mine to stop. Okay, so my robot is going to turn around and around. It's going to spin. And after spin it, I'm going to touch it. It's going to spin until I touch it. And when I touch it, I want it to go 5 seconds forward. Okay. Okay, so let's start. Let me just make sure that the wires are not getting in the way. They can be a problem. Okay, so I'm gonna run it. Okay, so it's not really spinning, it's just going around until I touch it. Okay, let's do that again so that you can see it. Okay. Oh, stop. And then we're supposed to spin. Okay. It's not singing. Okay. So that's exactly what Simtolile wanted it to do. It actually did sing. Did you hear that? Let's just run it again. It's because the motors are making a noise. Okay, you can stop it. Did you hear that? Yeah. Okay, so there's a delayed reaction because it's supposed to stop and then sing. But the communication between our motherboard and our motors is delayed. But the set of instructions has already been sent to the motherboard and then sent to the sound sensor before it actually stops. It's the same sort of thing as you thunder and lightning, where you can see the lightning before you hear the thunder. So there's an error with one of our motors and we need to just fix it. Okay, because it won't stop in real time. Okay, right. Okay, so well done, class. Give yourselves a round of applause. Okay, so now I'm going to open the floor for any questions from you guys, and any questions from the audience. Okay, before we go on to, all right. Do we have any questions on the webinar itself? Okay. Oh, and
Okay, Nonjabulo, we have one question.
yes.
It was posted at 10:22 on
Yes.
YouTube. The person asked, can I order the kit for my kids so they can also do practical?
Oh, yes, we answered that question, but let me just repeat that in case there are other people that are listening. So if you want to order a component kit, please email robotics@pvict.org.za. So it's robotics, R for rodents, OBOTICS@pbict.org.za. But we will share that on our socials, I think in the form of writing. Maybe we should edit our posts so that everyone just sees the information right there and then on writing. Okay. Any more questions? Okay.
No, from Facebook and YouTube, that's the only one.
Okay,
I think,
cool.
I'm sure we can check on Mentimeter to see if there's more there. Thanks, Nonjabulo.
Okay, so there's somebody requesting that next week can we have the session around 11 a.m. We will definitely have a talk about the times. We understand that some people probably have not been awake and etc., but you should be awake at 10 a.m. I will revert that question to the team. Thank you. Okay. I have a question. Oh, thank you guys. Okay, so we have a lot of compliments. Thank you so much, everyone. Yes. So a question that has come up is that, can a robot talk? Okay. Right. Who knows Siri? Right. So would you agree with me if I say your phone is a robot? You're right. Why? Yeah. Yes, because it's programmed. It has a motherboard inside. Right? Yes. Why else would you say? It also has a camera. Do you know that your camera can act as an ultrasonic sensor? Okay. Right? Okay. It can actually act as an ultrasonic sensor and also a thermal sensor, depending on the qualities that you put on the actual lens itself, and also depending, let's say you can also download an app, right? Yes, you can download an app that can enable your camera to be an ultrasonic sensor. It can measure the distance. Okay, right. Your phone is also an ultrasonic sensor besides the app, right? Who knows those professional cameras in iPhones that go in portraits? Okay, Simtolina takes a lot of photos of me. So there's this function that an iPhone has. It says go closer, or it tells you go back, or stand at least 2.5 meters so that you can take a nice photo. That feature is actually a form of an ultrasonic sensor. It has calculated the distance between the object, which would be the phone, and you. Okay, right. So the question that I'm answering, my apologies for going astray as I do, is that, can it talk? Yes, it can. Okay, you can create your robot to do anything that you want it to do, like Siri in a phone. Siri talks to you. Okay. Okay. Okay, Andrew says I'm supposed to ask questions. Okay, I am going to ask some questions that will just challenge what we've learned today. Yes, yes, a robot can draw. So, okay, so what I'm going to do is I'm going to take in any form of request that you want. So if you want to see a robot that can draw, I'll take that. My team and I will work on a robot can draw and we'll show it to you guys. Yes, it can. It's actually very easy to create a robot that can draw. Yes. And what about the questions?
Nonjabulo, there is a comment in the PBICT WhatsApp group. One of our members said he will need 3 kids. So thank you very much for inspiring more parents to invest in their kids' education in robotics.
Thank you so much. Okay, so we're also receiving about the parents being interested a bit more. So if you're interested, please go on to robotics at pbict.org.za. You can email all your queries there, but next time when we post, we'll definitely write that also on our socials. Any more questions? Can a robot do what? Bake. Drag a ball. Can it what? Sorry. Pop a ball. Yes. Or a balloon. If you give it a yeah, with the if you give it a needle, if so he's saying the question is, can a robot pop a ball? Okay. So a robot can do anything. So if you program your robot to move like this, like this, like this, and hopefully if it has enough force until it pops the ball, or if you program your robot to hold a needle and then it goes like this and then it just pops the ball. So you can. So the question is, can a robot kick and pop a ball at the same time? Okay, this is an interesting question. Yes, you can make your robot do a few things simultaneously at once. Okay. Okay. All these questions, I love them. Anything, almost anything a human can do, a robot can do. Okay, and sometimes even what a human can't do, a robot can do. Yes, like the Mars robot. Yes, well done. So we know that there are currently robots in Mars that are actually testing if we can move to Mars, né? And I'm one of the people that will be the first to move there. So yes, definitely.
Nonjabulo,
Yes.
can I just quickly share some of your viewers? A parent sent an image through PBICT's KZN WhatsApp group just to show some of your audience today. I'll just quickly share the screen.
We have a viewer. We love this. We can't wait for him to join us. Oh, he's already joined us.
Right. Okay, let me just speak to the audience so they can see it a bit better. I'll just hold it for a while.
Okay.
I wanted just to see the full screen quickly and then we'll go back. Yes, so this is, so this is our viewers this morning. So we're hoping to see more for part 3.
Yes.
Okay.
Yes.
Okay, I'll stop the share.
Okay.
Oh, wait. Okay, there's also a message from the Northern Cape, in the Northern Cape PBICT WhatsApp group, and they saying there's 5-year-old stakeholders are happy. On my side, Pres, they thank the president of PBICT Kids, Keda Louis. That's from Northern Cape. So they'd like to thank everyone and the president of PBICT Kids, Louis over there. With these,
so Louis, can you give your fans a hi?
And everyone in the class, just wave to you. Wait, let me just stop the share quickly. Lovely. Yes.
Okay.
Right. Yes. Awesome.
All right. So thank you, everyone. I'll just now have a few questions open up for the rest of the kids that were listening and the kids here to just remember, to just sort of see whether we remember what we've learned today. Okay. So the first question is, I'm going to give you guys around 30 or 1 minute so that you guys can all answer and so that the people at home can also answer. Okay. First question is, what is the first most important thing before you need to know and you need to understand before building a robot? Wait, 60 seconds. Okay, so the question is, what's the most important thing you need to always remember before you build your robots? Okay, answers on Menti, everyone. We also, our online viewers, we're waiting for your answer. Okay, we have 30 more seconds left. Okay. See.
Yeah, on outside, still nothing on Facebook and YouTube.
Okay. All right,
Yes,
cool.
but we're
So-
monitoring just to ensure that if there's any new
Okay.
questions, we'll let you know.
Okay, I got one answer there. Somebody read it out. Somebody saw it. I'm just trying to. Okay, so somebody said the first thing you need to do before building a robot is that you need to know how to program it. Sort of right, sort of there. You do need to program it, but there's one first thing that you need to do. Okay. So I'm going to then give it to the panel on the floor. Okay, so we're going to play a little game. The first person who has their hand up when they count to 3 will give me the answer, because all of you guys seem to know it. Okay, so so all your hands must be here, right? 1, 2, 3. Ente. Okay, so Ente put her hand up first. So what's the number one rule that you need to remember before building a robot? Listen to the instructions. Pay attention to detail. Okay, that's the most important thing, because if you miss anything, kaboom. Okay, right. Okay, so well done on that one. Okay, so please give me 4 types of sensors. Okay, 4 types of sensors. President of the Kids Association, Louis. For all 4 of them. Okay, fine. The second one, Simply. Okay, so touch, sound, yes, ultrasonic, light sensor. So I want you now to tell me what each of those sensors does. Okay, Louis, what does yours do? Okay. Yes, so it can detect, yes, sounds. Okay. Yes, Enfe. Okay, it doesn't make light. It senses, so it gathers information. So the same way you have your lights in your streets, you know how at 6 p.m. they all just come up, or at home you have, yes, so they first sense, is it dark? Is it dark enough? Then it goes up. So that's why you have your automatic cars. They first sense, is it dark enough for me? And then your motors cars, the lights go on. Okay. Okay. So inside your lights, that's a good question. Inside your lights, or even next to your lights, doesn't even have to be connected to your lights. You have your light sensor, right? So it's like a little electronic component. I'll show it to you guys soon, right? It's able to gather information on the intensity of the light. So by intensity, I mean, it's able to gather information on how bright it is or how dark it is, right? Once it takes that information, it sends it to the computer or to the motherboard. Then the motherboard is like, hey, it's too dark. The car can't see. Then the motherboard says, okay, please turn the lights on. So the lights go on. Right. So that's how it works. Next. Yes. Yes. Okay, so the distance, right? So she says the ultrasonic sensors can sense how far away or near the object is. So basically, it's the distance. Okay, right. Well done. Simple.
A touch sensor is when you touch it and then it does what you want.
Okay, so Simsolile says a touch sensor is when you touch it and then it does what you want to do. Okay, so some touch sensors are elaborate. Some of them can sense whether it's wet when something touches it, or something too. Yes, stay hands. Question. Oh, okay. We have more questions now. Thank you so much. If you play music and the robot dance. Okay, if you play the music, can the robot dance? Can somebody answer that question on the table? How? Using the sensor. How? How will it? Okay, that's lovely. Yes.
If you program it.
Okay, but how can we program it using what we've learned today? Remember, you can actually do it. So if you play music, can the robot dance? What sensors will you use and what outputs will you use to make that happen? Okay. Okay, close, yes. Yes. So the music, okay, so sound sensor communicates to what? The motherboard, and the motherboard communicates to what? It will communicate to the output, which is it will communicate the motor. Remember, it will communicate to the output, which is the motor. And then it will dance. Do you know that we could try that out with this robot? Right? Do you want us to try it out? Okay, so we're going to try out well, it won't really dance, it'll just move around. Oh, okay. There's a nice robot that can dance that Louis has for us. Yes. Louis, do you mind telling us who's the name of this robot? Oh. Okay, so there's a nice robot as well that we have from Louis. His name is Boxer. You can control him using an app. So is he gonna dance for us? Okay, so Louis is going to quickly make his robot dance for us using his app. Yo, that was short. Yes. Do you see that robot? It's dancing. Oh my gosh. Oh. Okay. Okay, so we can also make him sing. So he's singing. Mm-hmm. Wow. Thank you. Thank you so much, Louis. Hey, hopefully we can also build something like that, can we? Yes, you can. So we can build that. I'll show you guys. Okay. Okay. Oh. Right, so it says obviously that is a robot and they can build a robot. Okay, so I think this is the end of our second session. We're supposed to end at 12, but we finished a bit earlier because we chose an easier robots to assemble, which ended up taking not 5 minutes. Next week, I think we will start then the real programming, which is going to be a bit more in depth. So everyone will have their laptops and we will be doing programming. Okay, so we know how to assemble a robot now. The most important thing is to learn how to code. It's called coding. Okay. All right. So thank you so much, everyone. I hope it was informative and I hope it was fun. Remember, if you have any queries, please email robotics@pbict.org.za. Okay, so everyone say bye. 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 Okay, thank you.